Okay, let's start up again.
Oh, you got a thing.
Yeah.
Oh, nice. You want the microphone?
No, press that close enough to you.
Okay.
Okay, everybody. Attention. Okay. It's my pleasure to introduce our guest lecturer today, Gary Burke. He's been involved in prosthetics for more than 30 years and is currently a certified prosthetist and an adjunct clinical assistant professor and director of prosthetics in Stanford's Department of Orthopedic Surgery. And he also owns Gary and Burke Prosthetics Orthotics, his own business, named after himself.
Why not?
in San Mateo. He lectured both nationally, and he has lectured both nationally and internationally on prosthetic care, including the past 5 years in this course. And he's authored numerous publications, including over 20 book chapters, and mentored many student projects in their courses. He has a keen interest in investigating cost-effective technologies that enhance the lives of those who use prosthetics and orthotics daily. So a warm welcome for Gary.
Thank you. So yeah, 5 years here. It's fun. This is a fun class, and I like giving this talk because it's just, we're going to be a little interactive. We'll have some fun. I want to really force you to think about the world maybe in a slightly different way, especially when it comes to designing things for people. And so we're going to challenge you a little bit. I keep losing something here. Okay. Well, we'll just blink for a while. We'll see how this goes. My latest venture is this Medical Creations. It's a little bit of a startup out of Aspen, which is fun. But it's also sort of reinforced some of the things I've been teaching for the past 5 years. So you just get double down on all of this stuff. Disclosures, just because I have to tell you what I do for my life, and none of that has anything to do with today. So we'll bring it up, we'll start here, right? As you get older, you realize, and my kids will tell me every single day, I don't know anything. And that gets worse as we get older. This strapping young guy, 30 some odd years ago, down in the basement of the University of Oklahoma, started seeing patients and thinking that we can change the world and make these prostheses, and everybody who had an amputation had that possibility of being helped by whatever we choose to do. And it was fun, right? We were kind of flying under the radar quite a bit. We sat down in the basement and we did our little magic, and then people would do things and you get your name on surfboards and things like that. And so, I don't know. Oh, for goodness sakes. Well, I'll just stop. Forget it. I'm out. Okay. And then we got to, we'll see what happens. And then, you do a little bit of travel and you get into developing nations and you start to realize there's a real need for prostheses in the world. There's people that just don't have access. And so that you get very inspired by all of these things. And then one day was the Iraq and Afghanistan wars. And all of a sudden, prosthetics is at the forefront. All of a sudden, we're famous. And every engineer in the world has told us, you guys really don't know what you're doing. We thought we were great, right? But now all of a sudden we know nothing. And that's okay. We're doing okay still. And the internet comes around, and it kind of tells us that there's all these great options out there, and we still don't know anything, and we don't know what we're doing. But one of the things that's important is we have to realize that a prosthesis is a great tool, right? It's something that somebody has to wear all day, every day. But it's not an arm, or a leg, or a finger, right? It's a tool. And so we're going to play with this concept a little bit about how do you design things for people. And there was this great thing that happened when Oscar Pistorius came around, and I don't know if you guys know his social history, but we'll avoid that for a moment. And we'll talk about his skills, right? Here's a guy who's running in the Olympics. And they think, well, he's got these blades, he must be better than human. And so I always like to ask this question. How many of you all believe that prostheses can ultimately, we'll wait till that comes back on, will ultimately allow people to be better than human. Right? We saw it on the internet. It seems like it's a reasonable concept. Sure, why not? Bionic Man is a thing, I think. At least it was on TV in the 60s. I don't know. And so this is not an uncommon thing. And I usually ask how many people are willing to cut off their legs to find out, but we'll save that for another day. So how do we design things for people? How do we design something that somebody has to wear all day, every day, and relies on that to get around, to eat, to function? So I want to expand these thoughts a little bit and play with this. And I'm going to challenge you a little bit. And I'm going to ask you, if you had to design a shoe, right? We all wear shoes, or at least most of us. How would you start? What are the parameters? What is the goal? Go ahead. I'm sorry? You have a good sole, right? So what's the purpose of a good sole? Comfort. I like comfort, right? Shoes should be comfortable. Yeah. Meaning?
Walking on rocks all day.
Cool. So they protect your feet. I mean, that's the real purpose of shoes, right? You have protection. So you need, get there. That's really the function of a shoe, is to protect your foot. If you didn't have to protect your feet, like around the house, a lot of people don't wear shoes. So, okay. So we've got the function. We've got comfort. What else? Aesthetics. Right? They got to be cute. It's important. But shoes, that's a kind of an interesting concept. We're going to talk about aesthetics, and cosmesis is another way to put that. What else? Yep. Durability. Okay. Good. Yeah, they've got to last as long as you expect them to last anyway. Yeah.
How you tie it or strap it.
How it stays on. Okay. Yep.
Cost into account?
Cost. Love it. Right? Go ahead. It's got to fit. Right? It's got to fit. You can't take shoes from here and put them over here, right? You guys in the back have big feet. That's how this works. All right. So if we break this down, you guys did really good. Right? So we're going to 3D print a shoe. That's a good idea. This is Adidas, by the way. $420. You can have a 3D printed shoe. It probably lasts about an hour. But that may be an option. But what I really want to get at is all of those concepts, right? And I call them the 5 C's. And I think the 5 C's are things that we can use to design anything that humans have to wear. Be it shoes, be it prostheses, be it whatever. And you guys went through them, right? Comfort. Cosmesis. Sorry. Function. I can't think of a better word. Someone said conformability, but that doesn't really encompass function as well. So if you can think of a C word that fits for function, let me know. So I do that. Cost. And the one more that Dave talked about earlier is cool. Right? I think cool is really important. It never used to be important to be cool. Everybody wanted their prosthesis to look like their hand or their leg. Now, we want cool designs, we want cool feet, we want the coolest technology in there. Cool is really important. So we'll talk about all of these things in some detail over the next 4 hours, right? So we go back, I want to go back to this concept of better than human, right? These guys are pretty quick, right? Olympic marathoners. How would we go about making them better than human? Can we make a shoe that does that? Yes? I see nods. Tell me, how you design a shoe to make them better than human?
Jets.
What? I'm sorry?
Jets.
Jets. That's one way. Your feet go faster than the rest of your body.
Anti-gravity.
Anti-gravity is another one. Okay, so far we're really right in that realm of good stuff. Yep.
Leaf springs.
Oh, like leaf springs. So like Oscar Pistorius, right? So that would make them faster than human, potentially. Right? If nothing else, it makes them taller, which is the reason I have them. You mean something like that? Yeah. Who would wear this? All day, every day? Yeah, okay. I'd try it. That'd be fun. But think about this. Where does the pressure go? And how does that strap on? And how much of it ties directly to you? And how comfortable is it? And how cosmetic is it? You'd have to get your pants all rehemmed. Right? And in the end, does it really make you better than human? Right? Because the rest of you is still human. Right? You can only go so fast before you fall on your face. So it's interesting, I think about this a lot. We have this perception that 80% of you said, yeah, oh yeah, we're making amputees better than human. But we can't make humans better than human, and amputees are human, so I get a little confused by this concept. So think about that when we think about what technology can actually provide, because we all still really want to be human. It's a funny thing. So prostheses are interesting, and I brought a couple we can look at afterwards, and you can come up and play with, and we can talk about those some more. Prostheses are made from a mold, a very intricate mold of whatever is left. Right? We do it to every individual by hand. There are some CAD programs that do okay for some people, and yeah, that can go back and forth. It's okay. Once we get that mold, we make a positive model of the mold. So we have a duplicate of their limb in our office. We change that to add pressure, take away pressure, move things around for areas that are sensitive or areas that are stronger or more tolerant of pressure. And then we fit, and then we fit, and then we fit. And then we adjust, right? Because the one seed that we didn't really talk about was change. When you add pressure, tissues react and change, right? We'll have some examples of that coming up too. So it's this iterative process that takes hours and hours and hours and is individualized for each single patient that we see. There's got to be a better way, right? That's what everybody says. How do you do it? There's got to be a better way. You guys don't know anything. And we've gotten way better and faster at building products, right? We 3D print things now. How do we get the garbage into the computer to 3D print something? To think about that a little. But it's not really the building of the product, because it's not really that device that's the key here. It's that interface. It's that human portion of that, so that it has all of the 5 C's. That's the goal. We have this perception that this is what our future is going to be like. She's lovely. She's got these interesting little artificial things that are attached to her legs, and it all becomes one person in the future. Maybe. But the reality is more like this. This guy, he's our typical person who has an amputation. He's 85 years old. He's diabetic. He has no feeling in his feet. He has kind of lousy self-care. Right? Not everybody looks like Oscar Pistorius, unfortunately. That would make my life much easier. And this is part of the reason that all of this has to be sort of individualized. So let's dive in a little bit. What is comfort? To our C's. I love the C's. Well, comfort is, can you tolerate pressure? Certainly in a prosthesis. We're going to kind of go back and forth from prostheses to other things, but I live in the world of prostheses, so that's what we're going to talk about. Certainly it has to be a transference of pressure in a way that is comfortable. Right? You know when you have a pair of shoes that's not comfortable. It can't make noise. You know, a lot of this technology, a lot of the motors that we're developing and putting on people are kind of noisy. And I think a lot of people with amputations like to kind of just be normal. They want to go walk through the office and not have everybody go, oh, here he comes. It can't be too hot and it can't be too cold. That's hard. Right? I mean, anytime you encapsulate part of your body in a glove, whether it's silicone and plastic or leather, doesn't really matter, you're going to retain some heat and sweat. It can't be too hard to put on and take off. And it can't be too bulky, right? If you can't get your regular clothes over it. One of the things that's come out, there's a prosthesis called Limb that's out there now. And limb prostheses are interesting because they're really adjustable, and adjustability was really a great concept for us because the change is sort of one of ICs. So if things are changing, you want a prosthesis that's adjustable, it's really cool. Unfortunately, you can't wear pants over this thing because it's so big. So everybody comes in either shorts, and today would be fine, or they cut off the leg of their pants, which is craziness, right? It can't weigh too much, right? You don't want to, Dave alluded to that, you can't be lugging this thing around. It can't weigh too little, which is an interesting thing. We just learned that a few years ago, that if it's too light, then you kind of flies around and you don't feel secure. So you want it to be just right, whatever that means. And it can't hit those sensitive spots. Now remember, anytime that you have surgery, for those folks that have surgery, that have their amputations, there's a scar. Scars can be a problem. Nerves can be a problem. Right? So we have to avoid those super sensitive areas. And we've all had cuts that you poke at and you go, oh, that's not nice at all. So imagine every step, every day poking at that spot. So that's what comfort is in my mind. It's kind of interesting, though. It's hard for people to articulate what comfortable is. They certainly can tell you what uncomfortable is. All right? That pair of shoes that you bought and then you got home and went, ooh, I probably shouldn't have done that. Right? And because something could be comfortable one minute and not the next. Right? We change all the time. You go on a flight and your feet swell. Mine more than yours probably, but that's an age thing. But it happens, right? So if you get you change all day, every day, there's cyclical changes that cause your body to swell or bloat. It's that extra salt on your margarita the night before, right? So you retain fluids. And when it comes to something that has to fit intimately and comfortably, now you're fitting something that's rigid to something that's changing all the time. So comfort's a little bit elusive. It's hard. It's hard to stay comfortable all the time. Function is about, like we talked about with shoes, right? We designed shoes for protection. That's their function. That's their role. Do they do that? Right? Some of these minimalist shoes, maybe not as well as others. Right? But that's all function is to me. And is there a device out there that can do everything that you need it to do? Right? So this is a hook. We call it a hook. It's an upper extremity prosthesis for someone with a transradial or below the elbow amputation. And the hook's an engineering marvel in my mind. Right? It's lightweight. It's functional. Does exactly what we know it's going to do. You pull on that cable and the hook opens. And you get feedback through that, so you get control exactly how much pressure you put on something. Cheap. A couple $100, it'll last you 10 years. That's not bad. All right? But oh, is that ugly. Right? Doesn't really meet the cosmetic. Not really cool either. So it's got those two problems. But if we can get past the two problems, the function is unbelievable. You can pick a penny off of a table. No problem. You can pick up something out of your pocket without looking because you can feel it through the cable. And it'll go in your pocket. And some of these high-tech fancy hands, you can't get them in your pocket. What do we do with that? So function's an important aspect to me. The way this works is that it works actually off of the other arm. This guy lost both arms when building the San Mateo Bridge 10 years ago or so. Big beam fell on his arm. And we had him in some high-tech prostheses as well, but he likes his hooks. He's got hooks on both arms now. He can do anything. I've got video of him skeet shooting, playing golf, doing whatever he wants with hooks. Once you get past the cool part, function's the key, especially for both hands, because you got to eat. He can drive, right? And they work off of each other. As you pull the cable across your back, it opens and closes that hook. So you get that feeling and that sensation back, even though you can't feel exactly hot and cold, which I never understood anyway. Why would you want to feel hot and cold? Anyway. But the cosmesis is a real problem with that. Right? So, what does cosmetic mean? Cosmetic to you is going to be different than cosmetic to you. Right? This is cosmetic to him. Maybe to me, I don't know. Kind of like it. But what does that mean? And I think that has to be done on an individual basis. You like that, right? That's a good picture. And so it really is an individual thing. Cosmesis is really one of those things when we talk about glasses, when we talk about shoes, when we talk about shirts that we wear. Right? What is cosmetic to us is very different than what is cosmetic to the person sitting next to you. And a lot of it has to do with how you perceive yourself. And when you've had trauma or you've had an injury that requires an amputation, you've got to change now in your perception of your own body and how you want to display that to others. Some people will hide behind that, others want it to be out there. So this guy lost the 4 and 5 fingers. He wanted a hand. All right, that doesn't look too bad. Right? This guy wants to shout it out. And both feel that that's the best cosmetic option for them. So when you ask somebody, is this cosmetic, half the people will say, sure. And the other half will say, yeah, no, I'd never wear that. It's really a tough problem to sort of manage. And we do it in all kinds of ways because we can. Each device is individualized. And sometimes, occasionally, we will sacrifice comfort and function for cosmesis. Right? That does not look comfortable to me at all. I don't know if it is. Maybe y'all can comment. But yeah. And this is a common thing. Right? So that balance between comfort, function, and cosmesis, again, comes back to what's important at that time for that individual. And we have to somehow design devices and products and things to capture that. Makes it challenging. Cost was a good one. I like that. This is Michael Goldfarb at Vanderbilt. They designed this powered prosthesis and this guy climbed Empire State Building after 9/11. Right, with this prosthesis, which is pretty impressive, right? It's all powered. It pushed him up the hill. 250 grand, right? And the question becomes, what's it worth to the consumer? And if it costs way more, do you get that much more in benefit, right? Because a standard prosthesis can be anywhere from $12,000 to $70,000. So is this $200,000 better? I don't know the answer to that. Maybe to some. Right? So this is how cost plays into this sort of role in this discussion. The $420 3D printed shoes are those things that are worth it to you. Is it worth it to pay $1,200 for a iMac versus $900 for another machine? Right? These are challenges and discussions that we have all day long, and finding price point. How do you find the price point for your device, and what's it worth to people? It's really interesting, fun concept. So prostheses, because again I have to go back to that, that's our springboard for the day. Prostheses cost, well, we bill somewhere for this below the knee prosthesis on the left, that'll be about $12,000, $18,000. The above the knee prosthesis on the right, that gets up to 18, 20, 30. If you put some high-tech knee on there, it gets up to 60 or so. What we get paid is a very different story, because most of this is covered by insurance. And the insurance companies say, well, that's really cute. $60,000, that's nice. We don't think it's worth that. We'd like to pay you $20,000 for that. And by the way, you can't argue with this because otherwise you get nothing. This is our U.S. healthcare system. We get paid by device. We have to offer free adjustments for the life of the device. So time means nothing to us. So if we do it right and we get it in 4 visits, that's good for us. But every time they come in for a little adjustment, because humans change, we do that for free. So in the end, by the time the insurance company gets done with their madness, and we get done with all the parts and paying for all the stuff and the space, we have margin somewhere around 5%. Right? So when you hear these great numbers of how horrible we are because we're charging exorbitant amounts for prostheses, remember, 5%. Right? It's tough to run a business. It really is. It's not a standard business model by any means. In fact, it's probably one of the worst business models ever. Because a plumber goes and he puts in a pipe and he charges you $10,000. You have no choice. You pay $10,000. I have to have a discussion every week with someone who doesn't really know anything about prosthetics, about what they cost. So the numbers that are out there and being thrown around are artificial. They don't exist. It's nice to think about, but it's not true. So if you're in prosthetics to make money, congratulations, you're going to have to find a new job. It's fine. You do it because it's fun, and you do it because it's interesting, and you do it because it's challenging, and people are fun. Cool's a thing, right? People stand in line for 2 days for an iPad that if they went the next day, they could get it in 5 minutes, right? Because it's cool. And Dave alluded to it really well, right? This is really cool looking. So we got to have that, and that's the way we are with technology. In 2010, we did a great study looking at Afghanistan and Iraqi vets. And even if they stated that they were really happy with the prosthesis that they had, they all wanted the next cool thing. Even if it didn't have any function that they needed or wanted or desired or it would work at all. They just wanted the next cool thing. I thought that was really fascinating. There is always this, especially in this area. There's the, I deserve it. I have a few people, we also do some orthotic care. And anytime I tell someone that I don't think an orthosis is going to help them, they say, well, I should have it. I need to have it, right? Because I can't. And because I deserve it, and I should be able to get it, and I can afford it, and so I'm going to have it. No. So they want the next best thing until they hear the cost. Right, especially with prosthetics. The VA and DOD, Department of Defense, all get everything for free. So if they can convince their physicians, their VA cohort to pay for things, then they get it. Kind of interesting. I love the term bionic. Started in the 60s, not really a word, till Christina Aguilera said it's a word. Aguilera, sorry, I don't know who that is, but I saw this, I thought it was cool. And so, I don't know exactly what bionic means. We have this perception of this, and we call this a bionic hand. Multi-articulating fingers that grasp in kind of a cool and interesting way. That could be bionic, but I just don't really understand how it's different than this. Right? Does it really do anything different? Might do this. Let's see if I can get this to go. Oh, it's going to work. Cool. Okay. Fantastic, right? Was that amazing? Was it bionic? Think about it. What happened here? It's wonderful. She threw this little soft, cushy ball in the air, held her hand out, it hit her hand, and about a second and a half later, the hand closed. Cool. That's awesome. Watch it again. Right? I don't really think about that as bionic. I don't know. Maybe I'm biased. But I encourage and I give you permission to be skeptical with your optimism. You guys come into these things with this, like I always have, wide-eyed and ready to design, and we're going to make this great thing, and we're going to be a startup, and we're going to make millions of dollars, right? But skepticism is not a bad thing occasionally. And I'm pretty skeptical. It's kind of ugly, actually. But it's important. It's important when you think about design, especially if people have to wear your stuff. I think that's really important, right? These are cool. Glasses are really interesting to me. I wear glasses, but contacts, whatever. Can't see a dang thing. These actually are self-adjusting glasses. They're water-filled or fluid-filled, and they have little bladders and little motors, and they sense your retinas, and then they change according to what you need to see. So if you're looking down and reading, they're going to change their focal point. Pretty cool. Who would wear these? There's one in the back. Yay. There's always one, yeah. Why not? Why wouldn't you wear them? Go. Low visibility?
It looks
Yeah. They look a little narrow, maybe. Okay. Yeah. Why else?
That's more terrible.
Cosmetic, right? Glasses are really personal. That's why you go to the store and it takes 5 hours to figure out what glasses you're going to get, because there's just so many choices. And they all have to do with how you perceive yourself, right? They're cosmetic. It's important. So that's the first thing people will see, maybe, right? Unless you have an amputation. Yeah. How much does it weigh? A lot. Pound. All right. And we know, right, this is another great example too. Whenever you wear glasses long term, you get those little dents, right? Why do you get those dents? Weight, right? That the glasses are pushing on the soft tissue, the fluid's moving out, the tissues are changing, and you get changes in your skin. They come back, but, right? So, and that's with minimal glasses, low weight stuff. What about a pound? Yeah. So let's apply our algorithm. I'm in the way. Right? So glasses are great. Talk about functional, right? They do one thing. They do it pretty well. They allow you to see. That's great. What a great functional thing. Cosmetic, yeah, because you have 8,000 choices. If you ever want to see a great TED Talk, there's one called The Paradox of Choice. Yeah, you've seen it. I love it. Barry Schwartz. He talks about how when you have too many choices, it's hard to make any choice about anything at all. And then you're always disappointed in the choice you made because there had to be one better with all those choices. Anyway, cost-wise, you can tailor the cost of your glasses. You can get the special lenses and the non-reflective and the ultra-light, thin, super-duper, right? You have all these choices that you can make that affect the cost. But our self-adjusting doesn't really hit the mark on much, right? 2 of 5. And if you apply this algorithm to clothing, right? I mean, this sweater looks fabulous, right? But it itches, so I tend not to wear it. And so you have to balance all of these things out when you start thinking about other people wearing your stuff and when you make choices in your life. All right. I think that's funny. Really, this section should be called "Just because we can doesn't mean we should." It's a hammer-nail problem. Just because someone has an amputation doesn't mean they need a prosthesis. That's a hard concept for us to get past. Because we want to help people. We want people to be as functional as possible. Well, this is my friend Riley. He went to a local high school here, St. Francis, down in Mountain View. And Riley was born without his left arm, and when he was 4 years old, he came to see me and with his mom, and they said, well, is there anything new and great that Riley should have? And I said, well, is there anything he can't do? She said, no. I said, then I can't help him. So he went on, he played varsity football, he played varsity basketball, he played varsity baseball in high school, straight A student, went to Yale. Right? He came to me right before college, and he says, I think I need a prosthesis. Then I had this in my head, okay, it's cosmetic, he's going to, go to college. He goes, no. He says, I want to lift weights because my left side is weaker than my right side. Okay, we can do that. We made him a weightlifting prosthesis. That's all it did. One thing. Great function. He wanted it to be the colors of the school. I don't even remember what that was. And it was cosmetic. It did what he needed it to do. It was perfect, right? But again, he didn't need an arm to play football or baseball or basketball. And so this project, these 3D printed things, and I'm not sold on 3D printing anyway, but that's okay. There's durability issues, and maybe one day that'll be fine. I'm okay with that. But this is just plain silly. Is it cosmetic? Yeah, for about 10 minutes. Is it functional? If you go on the website and look up 3D printed hands for kids that Boy Scouts are putting together, which is a terrible business model, by the way, you'll see they all hold their arm out like this. Or they all hold their arm like this. Or they all go like this. right? Why would they do that? It's not fit, right? There's no human interface portion. It's just the hand. So if they put their hand down, it's going to fall off. Doesn't seem real functional, right? So again, great for 10 minutes, great for marketing, great for advertising. Cool. I'm giving them cool. But really, what's really the goal here? And maybe this young lady will do just fine with nothing at all. In the early, or 1865 in this case, A.A. Marks had a great company. I've got the book from 1920, where you basically take measurements of your limb and you send it in, and you get your prosthesis back. It comes with a mustache. And, things were okay. He actually looks not bad. He was able to get around. But is that really where we're going? I mean, we understand that fit is important because it's got to be comfortable. I don't know how comfortable that is. And so we've developed this concept of total contact, distribution of force over the greatest possible area without restricting range of motion. And that's what we think about when we fit prostheses. That's hard to do with measurements and over the phone and skin scans. And we have to appreciate that there's a fair amount of force coming through this, right? When Oscar Pistorius runs, right, there's a torque about this limb. And so if you don't have the alignment correct and you don't have that fit correct, it's going to hurt. No doubt. And so it's got to fit well enough to support all of that pressure, to be comfortable, especially during running and high loading activities, to transfer all that pressure to the human. Right? So I'm not sure we're going to get to 3D printing yet. Maybe. Next section. I like that picture. It reminds me of Aspen. One of the surgeons from Mayo was talking about this, and I thought, what a great line. Right? What a great concept. She is. And the point is this, that everybody is different. Sometimes they look different. Sometimes they have things going on in their heads that we don't know so much about, that are hard to figure out and hard to diagnose. This young lady came in with this wound on her shin there, or up on the side of her knee. And the first thing you do is go, oh my God, we've got to treat the wound. But the real problem was this. Oh, this bony overgrowth hurts. And so the problem was really just a symptom of how she tried to solve the real problem, was pain at the bottom. So we can't, it's hard to adjust a prosthesis and have someone say, here's what you should do. If this happens, then this. But the real problem you can't even see. And without having those questions and having querying and spending the time with people to understand the base problem, you're treating the wrong thing. And how do we do total contact, total surface bearing on something like this? And again, it comes back to change. We have to know and understand tissues and how they're going to change under pressure. What happens when we apply pressure to this big bulbous limb? Well, it's going to shrink and it's going to change. And we know in 6 weeks or 8 weeks with a prosthesis, that prosthesis may not fit anymore because that leg's going to change so much. And so it is this iterative, ongoing, soft tissue fluid management problem to wear a prosthesis. And it's probably the same in wheelchairs. It's probably the same in people who do anything long-term with a device. Right? Tissue changes over time. I, of course, look the same as I did in 1964, but that's not important either. So this idea of Vendalim, I don't see it happening anytime soon. There has to be a fit, there has to be comfort, and there has to be function. I'm not sure you can get that from a vending machine. Maybe. Okay. I don't know what happened.
Advance it?
Yeah, maybe. All right, I don't know. Do you want to escape it and we'll try again? Okay, now let's play. Right at the top. Yeah. Okay, we're good. Woohoo! I love technical problems. All right. So, this is part of the DARPA project that David talked about earlier. This very nice, very lovely gentleman was an electrician, a high wire guy, and got zapped and blew off both his arms. And he's been wearing this right prosthesis for about 15 years. DARPA comes in, puts about 75 grand in. They do a surgery called targeted muscle reinnervation. They move the nerve into the chest wall. They separate out all the nerve bundles, and now he has the ability to control the elbow, the shoulder, hand, and various fingers. Totally cool. The entire device weighs about 22 pounds. Now, I know most of you have worn backpacks, right? At some point, you got to get that thing off. Right? And that's not quite 22 pounds, maybe, some of y'all. Engineering school, right? They're 22 pounds. So it's interesting. So people see this on the internet, and they say, oh, I've got to have that. And you say, well, it weighs 22 pounds. They go, oh, maybe. There's another young lady that I saw that had one as well, and she told me straight up, I just can't wear this for more than an hour. Right? So maybe it'll get smaller. 22 degrees of freedom's tough. Right? That's a lot of control mechanism and a lot of management and a lot of cost and a lot of dedication. Right? It takes time to learn, takes time to dial in, but kind of cool, for sure. There was this thing called the Cybathlon in Switzerland. Cybathlon was really cool. It basically takes people with various disabilities, and there's a whole upper extremity prosthetic section, and it's all designed to highlight technology. What cool technology is going to win the Cybathlon? Right? Well, the guy that won was the guy with the hook. Senator Duckworth from Illinois was a helicopter pilot, blown up over Afghanistan. Will tell you that Steve Jobs is probably right. We need to have a goal before we apply technology. We're not drug companies. Drug companies start with a chemical and say, oh, let's see if it does this. Right? That's not what we should be doing. We need to have a goal in mind and a focus, and then design around that. And don't forget, they're humans. Thank you for your time.
Gary, you said you had some examples.
I've got some examples, and we can talk about questions while I pull these out. Thoughts? Questions, concerns, something that I said doesn't make sense, that you don't like? Are you all fans of 3D printing? Yeah, go ahead. Practice. It's really not hard. No, it's just a matter of using that. It's a split hook, and it works in that direction. And so you can actually just move it to this, open it, move it to the side, and pick it up that way. And because you can feel, and you can see, thank you, yeah. You can see, because hooks, right, they don't block the view. So you can see what you're picking up. That helps too.
Why don't you just describe the leg?
Sure, and then there's a question here as well. Yes?
This other piece, does that end up the user is paying that, or does that just get lost?
It depends on the weather. Often is lost, or a portion of it's lost. Oh, you scared me. I thought it was falling. Yeah, it's a rough business model for sure. Above the knee prosthesis, this is one that's being delivered next week. So it's the latest, greatest. 1 second, I'll get right there. Microprocessor controlled hydraulic knee. Okay, very cool. Actually, very functional. The knee senses where it is in space, and if it's here, it's stiff. If it's here, it's free. So it swings through easily, but we find that because it locks itself out, it's incredibly safe, and therefore people fall down less, and I like that.
Following questions.
Yeah.
I was going to ask about, you mentioned that you made a prosthetic or prosthesis that allowed him to lift weights. Is it most common that you make something that allows someone to actually do one activity, or is it more common to have a daily life?
Yeah. people want as much as they can out of their devices, right? But I don't know of a single device that does everything. And if we counsel folks ahead of time, like Riley, then he comes into it knowledgeable and say, well, it's much better if I just have it do this, and maybe I need 2 prostheses. One to do this, one to do that. That's a much more reasonable model to me than attempting to make one device do everything. It's like having track shoes and ballet shoes. Go ahead.
How much of a problem is balance?
Balance is a weird thing. Balance is, did you all hear that okay? The question was, what about balance, essentially? Balance is hard. If you've got someone who has good balance, good strength before, they'll do fine. Balance isn't really an issue. But a lot of our patients have all kinds of other comorbidities, all kinds of other problems, balance issues, diabetes, circulation issues, can't feel their feet. And balance is a problem before their amputation. So if you're young, you're from Afghanistan, and you're in perfect physical condition other than this amputation, balance and function are less of a problem. Yeah?
For someone getting a prosthetic, what does the timeline generally look like from when they first see going out to get it?
Yeah, it can be months, depending on the complexity and the timing and how recent of an amputee they are. We want to get people up early, so new amputees, we get on something. Something's better than nothing. But as we go down the road, we put in more steps to assure quality of fit over a longer period of time. And so that time extends a little bit. And for some of our tougher cases, this guy's kind of difficult in his own way. This has taken months. Yeah.
Sometimes they see you before they're even amputated.
Yeah. So I love to see people before their amputation, because then they go into this with an expectation of what's going to happen, rather than the internet and rather than what they believe. Because people in that situation who've had a new amputation often have no idea what to expect, what they're going to be capable of. Am I going to be able to ride my bike again? Can I play the piano? And my first question is, did you play the piano before? But that's different. So there's that balance of changing expectations with early intervention, and I love that. Yeah.
You emphasize a total surface area.
Yes.
So what do you do in that kind of interface? And Volsky, or what do you do to increase the comfort?
Yeah, so what happens is, like that big bulbous leg that I showed you, we try to shrink it down as much as we can with shrinkers and elastic socks and, like Ted hose types of things. And if we can get some fluid management, that helps a lot, changes the shape. And then we pad and adjust and cut out parts of this prosthesis. We do all kinds of things to maintain that fit as long as we can. That first prosthesis really only lasts 6 months to a year. And then they get another one that should last 3 to 5 years, give or take, depending. I'm sorry?
No gel cushion?
No, well, gel is interesting, right? So if you think of cushion, if you make it too cushy, then when you move your leg forward, the prosthesis doesn't come with you till 5 minutes later. So you can't make it too soft. Can't make it too hard. So you find these balances in materials. So yeah, there is some cushion in some places.
Okay. Amy has the last question.
Yeah.
So the TED Talk where the MIT professor
Yes.
talked about his dancer.
Yeah, Dr. Herr. Yeah.
What makes that prosthesis special? Like the lady was able to dance.
Well, we have people that dance on prostheses that aren't that special. It's a desire thing. There's a perception that high tech is better, right? And if you ask Hugh, that's going to be the greatest thing that ever happened was that prosthesis. But it doesn't really fit my C's all the time, right? It's noisy, it's heavy, it's expensive. So it doesn't really fit, and it's actually not doing that well in the market because no one's paying for these things because it doesn't provide that much added benefit. So the adjustability is nice, we like that, but there's feet that adjust. So it's a little bit of salesmanship, right? I don't know that it's that special, to be honest.
Let's give Gary another round.
Thanks.
So we're at the end of our class time, but if you can stick around and want to come up here and talk to Gary and check out these legs,